Bismillahirrahmanirrahim. Greetings. The subject in this video lecture is about completing a square that leads to a very popular formula. Now, the subject is one of the topics that can be found in any basic algebra textbook, and I intend to present it at the same level, basic algebra level. Now, at the end of the video, if the time permits, I will also make a not too long talk about the related history to this subject. Now, I'm using very primitive equipment, and I don't also have somebody behind the camera to zoom in and out for me, so I will be doing that myself mechanically. And hopefully with this handicap that I have, no chalkboard or chalk and primitive equipment, I can still convey the message, convey the knowledge to you. And hopefully you will benefit from that. And hopefully you will also pass it to others, and hopefully others, they also be motivated to watch this video. Alright, let's start, shall we? Now, a good car mechanic always, when he wants to do some section of the car, work on it, he puts the tools that he needs on the table, and it makes him kind of more efficient and more kind of effective and more disciplined. So in contrast, I'm intending to do the same thing. So I'm going to give some preliminary material that we'll be using for the rest of this discussion. Okay, and then after that we start the body of the subject. Okay, the preliminary will be about a few axioms. One of them is distributive law of multiplication over addition, that you have heard it, and now that I put this one up, I go and zoom it, so that from now on you will be seeing this one. I don't think it's very visible, but when I zoom it, I will stand out of your way, so that hopefully that will be very nice and focused and visible to you. Okay. Well, I hope that is now is visible to you. That is distributive law of multiplication over addition. You have already heard that. And that is an axiom, is a property. An axiom is something that in mathematics we do not have to justify. Because mathematics is very meticulous subject. And everything that you say and every step that you take, you must justify. And there is no such a thing as you say, is my opinion, or is intuitively I feel that way. You must justify that step. And justification comes based on axioms, postulates, definitions, and previously proven theorem. So this is one of the axioms. And again, I repeat myself, axiom is something that is kind of building block. It's the only one that you don't have to justify. You can say based on that axiom. Now, postulate is same as axiom. It's only for particular subject. Like for example, for geometry, they don't call it axiom. They usually call it postulate. But they are same and they have same meaning. Now, here is one of the axioms: distributive law of multiplication over addition. A, B, C are assumed to be number. So A times B plus C is A times B, A times C. And you can put numerical number and show it for yourself. For example, if A is 2, B is 3, C is 4, 3 and 4 is 7, 2 times 7 is 14. And that is same as if you multiply 2 times by 3, which is 6, then multiply 2 times by 4, which is 8, 6 and 8 is what? Is again 14. So the results are same if you do it either way. But this is called factor. This is called, because there is addition between these two, they call them terms, just terminology. Now, The other way to do that, not to get a little bit confused that you think A should be a single number, it can be an expression. So let's say if I, in live class I put maybe a rectangle here, and I put triangle here, and I put circle here. So inside rectangle, inside triangle, inside circle can be any expression you want. Does not have to be even number. So in that law, you multiply this is, in this case, this is my A. You see that? So all of this times B, all of this, which is A times C. My C, as I have put arrow, you can see that hopefully, is represented by B, and my X is what B represented by X. So I end up with this one. X plus B times X plus B times B. Now again I can apply the distributive law of multiplication over addition, this time from right to left. Doesn't matter, because multiplication is what? Is commutative. Commutativity is also another axiom. Like 2 times 3 is 3 times 2. Now, if I do that, I come with this expression, and because at this stage of basic algebra, I'm sure you know how to combine like terms, and after doing that, I come up with these 3 terms. Alright, now I go, this is again my kind of preliminary, if I'm pronouncing it correct, and then the main body I will start. Okay, now the other way to look at it, A times A is A squared, where A stands for number. Like 5 times 5 is 5 squared. This is my A and this is my A, they are same thing. So this is A squared. And then by binomial expansion that most of you are already familiar, you can say is a square of first plus twice first times second plus a square of second. Are you with me? Now, in the previous one, the one that I used, distributive law of multiplication over addition, in this one, the students, when I come to here, say, hey, why don't you multiply this by this and make life hard? Foil it, the students say. What does foil it mean? Foil, the word foil is not mathematical terminology. I don't know where it comes from. Is it aluminum foil that you foil something? And unfortunately, some of the textbooks are using that word and showing with arrow how to complete that. And I strongly disagree with that, because it makes the justification goes away and make a student mechanical, like a cookbook style of presenting. Follow recipe, do this and this and this, you get that one without any justification. Just take the food on the end and eat it. It comes very delicious. Don't ask me why I add this much and this much. I absolutely disagree with that, and that word I have written here, the word foil, is not a mathematical terminology, and there are some other ones, unfortunately, some even experienced instructors, they use it, but it's my personal opinion that I stick with the terminology, and I also demand justification from my student, everything that they say, seeking for example and counter-example, etc. But anyhow, if at the time comes, I may go over that also. Okay, then I'm done with the so-called preliminary. And this stuff we're going to come back again and again, and this subject is going to be really based on this preliminary. Alright, now let's start with the main part, the body part of the lecture today. And that is, suppose that we want to lay carpet in a room which is a square in dimension. X plus b by x plus b is the dimension of the room. This part is cut off maybe for oven or what have you, maybe maybe washer and dryer or whatever. Now, if this is a question that we can ask, that a grade school student can answer it. When you ask how do I find this area, they say, suppose I want to go to Lowe's or Home Depot and find carpet and carpet it. He say square it. He used the word square it. which means x plus b by x plus b, whatever x and b are, and then go and that dimension by the carpet and bring it back and cut off from that a b square. Now here, x is a variable. The name says it all, which means subject to change. Now, x can assume, in this case, all positive real numbers. It can also be 0 in this case, but when we go to algebra, x can assume any real number. And then b is a constant. Again, the name says it all. Constant means what? Means does not change the value. Like 3 does not assume 4 or does not assume 2. 3 remains 2 for all is the entire discussion that you're using 3. So same is true with b. But again, x is subject to change and has, in this case, infinitely many values that x can assume. But at the end, we will see that it's not the case with some other way, that x is there, that x is not unknown, and that comes for conditional equality, conditional statement that makes x, if it is not identity, makes x to be having a finite number of values it can assume. And those finite values that x can assume cannot assume anything else. But this x can assume everything, in this case, every positive number. Okay, now we go and see how we can find the area the way that our grade school kid told us to go to Home Depot or Lowe's and get the carpet and bring it back. And let's see what we can do in that case, huh? Now here, hopefully again is visible to you. And here, the dimension of the room that we were going to lay carpet was, I'm out of your way, huh? It was is x plus b by x plus b. That is the area of what? The area of the square, area of the entire room. This part we want to cut off, that is b by b. So this is x by x plus b times x plus b, or x plus b by x plus b dimension of that, less, minus b by b, which is b squared. So I wrote that one, and then we came up to this expression, and look what happens. B squared and b squared, they cancel each other. They are additive inverse. So they cancel each other to 0, so I'm left with what? The area of the figure, algebraic representation of the area of the figure, if I'm correct, is x squared plus 2bx. So this is an algebraic representation of this area. So far, when we clean this one, this is a complete square, which is x plus b quantity square. In the previous page, I did show it in preliminary, and then will be minus b squared. This should become. So if you expand that one, you get this one. This minus b squared stays there, and these two, they cancel each other, so you are left with this one. Hopefully you are comfortable so far. Okay, now I'm using geometry as a visual aid. Now the visual aid that I'm using for geometry is over. Now algebra, pure algebra takes over. And from now on, we are not using geometry, but discussing about the algebraic part of it. Corresponding algebraic expression of that. Okay, so far so good. And I have this one, by the way, if you want to write it, doesn't hurt. Let me put it up and I wait. You can always pause and your camera, your computer, and take a note of it. This is the area of the entire carpet laying is this. Then minus what you want to cut off, b squared, and this becomes the area of what? The area of this geometrical figure, and the rest of them is algebra, where they come from. Just representation of that. But anyhow, you can take, if you wish to take a note, you're welcome to it. Okay, now let's go to the algebra part of it. Now the visual aid of the geometry is out. Now we're going to use the algebra. Now suppose that we are given x squared plus 2bx, and we are asked to complete the square. So we know from the previous example, the geometry that we use, we know how to do that one, huh? Now, here, to complete the square, we say that previously we had b squared. So where does b squared come from? We look at that and we see b has no relation with x. Is that right? But b seems like it's coming if we take the coefficient of x. Coefficient is something that usually comes to the left of the variable, or more often they are numerical coefficient, we can call them in this case. So coefficient of x in this case is 2b, and then b is half of the 2b squared. So we get the feeling that if we take half of the 2b, half of it, square it, then this becomes complete square. Let's see if it is correct. I take half of that, square that one, and I end up with what? This square. But, there was no b square over there. This is what given to me, and they say complete the square. I have no permission whatsoever to change what is given to me. I can only do some cosmetic makeup. I can put some makeup on that to make it a little bit pretty looking, but in reality, this must not be changed. But when I add b square to complete the square, I have changed it. So I have to compensate with that change. So I subtract b square. So in other words, I add b square, I subtract b square. And what is b square? Is half of the 2b. Half of the 2b is what? Half of the coefficient of x. Okay. Now these three always give me a complete square. Always under these circumstances give me complete square. But to make my heart to be comfortable, I always check it so that I make sure I have not made any mistakes. So far so good. So again, this gives me complete square. The complete square of that is x plus b. Is that right? Quantity square minus b square. As a matter of fact, now I have difference of 2 square. I already discovered the formula. And this formula has application in when we go further for sketching parabola. This is the constant, and this tells you how the parabola, you can move it left or right in Cartesian coordinate system. But anyhow, a little bit maybe when the time comes I talk about it. Okay, now let's go to next one. So by the way, next one is nothing new. I just put it in writing so that if you wish to write the notes, you are welcome to that. And that is what I just said, I put it in writing. So you take half of the coefficient of x, square it, add and subtract, which means you are adding and subtracting same thing. They are compromising one to the other one. So you are not changing what was given to you. By doing that, a complete square comes out of it. All right? So this one is out. Let's go now to next. So now I have a question to ask. The question is that previously, as you noticed, you have 2bx. Is that right? The expression was given to me was x squared plus 2bx, and they say complete the square. Then you say, okay, every number times 2 is even number. Is that right? 2 times any number is even. That is not true. That is not true. Any number times 2 is even provided that number is an integer. So when I say multiply by 2, then you say, okay, I multiply by 2, add and subtract, it looks like they are all even number. Now, for instance, if I have an irrational number like 3 over 2, then in the formula previously, twice first times second, 2 times 3 over 2 gives me 3, and 3 is not an even number, it's an odd number. So the recipe that I gave, I had to use that word because I had to say that I'm teaching like a cookbook style. But the recipe that I gave before, take half of the coefficient of x, that the coefficient of x does not have to be an even number. In this case, is 3b, whatever b is. Whatever b, this could be even, if b is even, could be odd. If odd, it could be even, a square root of 2 can be pi, can be anything you want, any real number in fact. Now, here, I take half of it, you see, half of the 3b, between 3b divided by 2, square it, then compromise with that change. How do you do that? Subtract same thing. So you add and subtract same thing. But what are you adding and subtracting is half of the coefficient of x. By doing that, the first three terms always give you complete square, and the second left over step is algebraic, what is manipulation. You leave it next to that. Now, right now, if you are, for example, working with the parabola, this it can tell you if you move parabola to the left or right, up or down. All this will help you. So when you go to the section of parabola, this completing a square comes very handy for sketching the graph. This makes it much easier to do that. Okay, now let's go to the next. Now let's generalize this idea. Generalizing means what? Means we can use algebra rather than any particular cases or numbers. So let's generalize this one. Now here the coefficient of x, I wrote a capital B. Capital B can be expression, can be any number, can be a square root of 2 again. I mentioned that can be pi, can be e, can be rational, can be irrational number. As a matter of fact, can also be a complex, but that is beside the subject. Now, I take half of it. Half of b means b divided by 2, is that right? I square it. I squared it. Now I change what was given to me. I have to compensate with that change, so I subtract same thing that I have added. So these two are additive inverse of each other. They produce 0. 0 is identity for addition, and any expression or number plus 0 it remains the same. That's what they call zero identity addition. Now, this 3 gives me complete square. I wrote it. Then minus this step. Do you follow me? It looks like difference of 2 square. So this is kind of in general I did that B stands for what? B stands for any expression, any number, any real number in fact for that in this case. Okay, now I have one question to ask, and let's see if you can answer it. The question I have is that we didn't really have x squared plus bx over there. We had x squared plus bx. There was a third term. Third term here. There is a third term. Do you see that? Do you see a third term? So I covered it. Now I'm going to uncover it. The third term is 0. Let me uncover it. Here you are. The third term is 0. So there are really 3 terms in this case. Now why did I put that? Because 0 was not playing any role of completing a square. Completing a square had only to do with coefficient of x, half of it, square it, add and subtract. Is that right? That's what we were concerned. Now here, what about if this is not 0? What about if a non-zero number as a third term? So I wrote this one. What about if you have an algebraic expression like that and they say complete the square? What do we do with c? So as we didn't do anything with 0 here, we don't do anything with c either. Stand back, stand by. Our president, Donald Trump. Stand back, stand by. So the c is going to stand back but stand by. Stand back but stand by, and it comes back to the picture. As far as completing a square is concerned, he's standing back. So let's do that. We take half of the coefficient of x, square it, add and subtract. Is that right? The first 3 I've already, you can do it very even in your head. The second one, this has a square of first, twice first times second is this, plus a square of second minus this square. They cancel each other. So what was given to me didn't change. But now c stay back, stand by, now it's coming back. The rest of them is algebraic manipulation. You take common denominator and add them and make it one term. You can also leave it like that. Okay, then we know about this one, and because you're working with your computer, you can always pause and repeat again and write your notes, so that, you know, in regular class I usually go a little bit slower and give students to breathe. But you have the more kind of access of pausing and repeating and writing notes accordingly. Now, so far our focus was on the coefficient of x. We take coefficient of x, half of it, square it, add and subtract. Now the question is, what about coefficient of x squared? Have you noticed by doing that the coefficient of x squared, all of them that we were doing, the coefficient of x squared was 1. What about if the coefficient of x squared is not 1? Is it also a stand back, a stand by, or there are something else we can do? So let's see what the role of the coefficient of x squared will be if it is not 1. Like this example I made. Now if this example I take half of the coefficient of x, which is 2, half of it is 1, add and subtract plus 1 and minus 1. Is that right? So this is not changed. This 3 should give me a complete square according to the previous recipe. Let's see if it does. I write 3x plus 1, then a square, and see that the square of first is 9x squared. I didn't start with 9 squared, I started with 3 squared. So that's it, you don't have even continue, you know, you have done something wrong. You don't have to say twice first time second. It's 6x, I don't even have 6x here. So something went wrong. So this 3 was not a stand back and a stand by. This 3 is different than C, the role of this 3. The role of the what? The role of the coefficient of x squared. So let's see what we can do so that we still be able to complete the square. So what we do, as I mentioned it in preliminary about what completing, preliminary about distributive law, multiplication over addition, which is same as factoring, is an axiom. Let's now discuss that one. So what I do, I factor 3 out. And there is a 3 here. This is same as 3 over 3. 3 over 3 is 1, and 1 times any number is itself. 1, they call it identity for multiplication. I call it the skinny one. And there is a skinny one. The skinny one is 3 over 3. So when you factor 3, this one of the 3 of the second term comes out, the other one remains. So test it to make sure you're right. When you multiply this by that axiom that we mentioned in the preliminary, which is for the axiom that this times this times this, multiplication over addition, this times this is this, and this times this is this 3 and this 3, they cancel each other, so you're left with 2x. Yes, fantastic. We haven't done anything wrong. So now 3 stands back. But not like C, the other different way stands back. Now let's see how he can come back, stand by, when he can come back, when we need it possibly. Now here, the 3 has no role now, the coefficient of x squared is 1, so we go ahead and take the coefficient of x, half of it, square it, add and subtract. I have done it here for you. Here you are, add and subtract. Now, one very, very important thing that we all make that mistake, this 3 gives us the complete square. That's correct. Now, this is not free unless you multiply it by 3. Because 3 is a factor, 3 times all of this, 3 times all of this. You remember the distributive law of multiplication over addition? This all now is your A, and this is your B. So this times this times this. This times this gives me 3 times complete square. Then when I bring this one out of parentheses, I do not have to forget that it must be multiplied by 3. Otherwise I have made mistake, and that's very bad common mistake, we all make it. So here I have half of it, square it, is that right? These two and these two, they cancel each other, so I'm left with 1/3 square, which is 1/9, is that right? 1/3, but these three should multiply by that, so become really 1/3. So hopefully this is clear, and you can pause and write it. This is the tricky part of this completing a square, that many of us make mistake, and unfortunately we lose point in the test or quiz. Okay, now let's go to the next question. Now I have another one. Let's see if we can generalize this one, what we said, and see what we can come up with. Now the generalization is that the coefficient of x squared is a, and a is any real number. When I say real number, can be pi, can be a square root of 2. Any real number except 0. Common sense, because if a is 0, he kills this one. Then we are dealing with a linear. There is no, we are not talking about what is a completing a square. There is no square. Okay, so what do? We factor a out, we take, this happens, then we take half of the coefficient of that, which is b over 2a squared, add and subtract. And then c, you remember, stand back, stand by. Now is also coming, combined together. And these three always give me a what? A complete square. And this one you can either leave it like that or go ahead and have common denominator and write it as a one single term. So here it is, we come to this one. Now comes what? Comes the moment of the truth. That, do I have it now? The moment of the truth is that now, I forgot to mention it in this case, not only I generalized it, but I also set it equal to 0. Equal. So I used equality, because equality is equivalence relation, and causes partition in the equivalent classes in the partitioning. But anyhow, I'm not talking about that, I'm talking about this. The reason I set it equal to 0, because now I have more tools. Excuse me, I say equal to 0. The reason I use the equality, because I have more tools. And what are the tools? I can multiply both sides of equation by any non-zero number. Is that right? I can divide both sides by any non-zero number. I can add to both sides any number I want. I can multiply, I can divide, I can subtract both sides by any number I want. So the equality gives me now much more tools to work with, because I'm dealing with algebraic manipulation, and see by doing that, what do I come up with? Curiosity killed the cat, but in this case, curiosity makes Einstein. Okay, now I go ahead, the rest of them I already mentioned. I factor a out, complete a square, I end up with this expression. Now, let's see what this expression does to me. Now, because I'm dealing with equality, as I already mentioned, you can do to both sides of equality same thing. The equality is not changed. As long as the equality is preserved, which we are permitted to do that. Okay, then we are now taking advantage of equality and see what we can come up with. Now, when I use the equality, look what happens now. Let me see, I'm here. Now, in the previous one, what did I do? I combined the terms and made a one term out of it. Now, since these two are equal, so I can do whatever I want in both sides of the equality. So in this case, I take a square root of both sides. When two numbers are equal, their square root are equal. Is that right? The converse is not correct. Okay, now when I take a square root of both sides, again I have done it, a square root of 4a squared becomes 2a, and this goes outside radical. And when I'm taking a square root, you see a square root of 4 is plus or minus 2. Because 2 squared is 4, minus 2 squared is also 4. But the principal square root of 4 is not plus or minus 2. The principal square root of 4 is 2, is the positive root of that. In this case, I put plus or minus because I'm not talking about principal square root. I'm talking about the two possibilities. Alright? Now, here I take a square root of both sides, I end up with this expression, and then this doesn't have any more 2, so x plus this, I bring that one to the other side, minus, and I do again same denominator, I write one denominator, add numerator, and here it is, a star is born. And what is the star is born? We call it what? We call it quadratic formula. Now, there is something very fascinating in here. Number one, notice that this x is different than the x that I initially used for the x by b dimension of the laying carpet on the floor of a room. This x is different. That x could assume any variable, any number he wanted, but not this x cannot assume any number. In this case, there is only 2 or maybe none value x can have. But look what's fascinating situation. A, B, C, they are constant. We know what constant is. Like 3 doesn't become 4, 3 doesn't become 2, we call it constant. They are constant number. They are coefficient of x squared, x and constant number c. And look what happened. The constant numbers are telling me what is the value of x. Isn't that fascinating? You see, I beat them up, I took them inside the jail of radical, the constant numbers, and finally they did betray the value of x. The value of x either plus or minus, or can be 2 or none if it is real. Of course, I haven't talked about that, but later on you will see that in the set of complex number, 100% you will have 2 solutions for that, 2 unique solutions for that. That is very fascinating. Now, the time is getting a little bit too long. I was going to talk about the related history to this subject, which is very interesting, again to the level of basic algebra, but with your permission I postponed that one for the another video that, as a matter of fact, right now I'm going to do it. So I'm going to put that one for you, and that gives the related history to this subject, which is very, very fascinating. Just briefly, I tell you, is that what happens if we have the expression like ax cubed plus bx squared plus cx plus d. How do we do that one? Can we still use a, b, c, d and find the value of x or not? How do we do that? Where does it come from? What is the formula? Is it formula similar to that or different, etc.? I'm going to talk about that for a shorter. And I do encourage you to watch that one. That is the flavor of this one. Gives you some historical background, and also there is some good motivation for that one. Okay, then I hope that I have conveyed the knowledge, the message for you with this handicap equipment. And until soon coming video, follow this immediately. I wish you all prosperity and success. Alright, I didn't zoom it on so that you can see me better, but you have already seen me, huh? Alright then, so long.